So let us now calculate the variance of the negative binomial. So as a recap, the PMF of a negative binomial random variable is given by this expression where x can take any value from 0 to infinity, all whole numbers, and the mean, as we calculated earlier, can be given by this expression here. Okay, now for the variance, what do we need? We start with the second moment. So second moment is x squared x plus r minus 1 r minus 1 p to the r 1 minus p to the x, and then x goes from 0 to infinity. So as we did in the calculation of the mean, we will use this relationship x times x plus r minus 1, choose r minus 1. This is equal to r times x plus r minus 1 r. Okay, so our second moment then will be equal to r times x is equal to 1 to infinity x times x plus r minus 1 r p to the r 1 minus p to the x. Okay, so now let's make a change of variable here. We say k is equal to x minus 1. So then e to the x squared, not e to the x squared, expectation of x squared, this is equal to r times k is equal to 0 to infinity k plus 1 times k plus r p to the r and 1 minus p to the k plus 1. Now just for simplicity, I am going to bring 1 minus p outside, so this will be r times 1 minus p times k is equal to 0 to infinity k plus 1 k plus r k plus r k plus r p to the r 1 minus p to the k. Now let's split it into two separate summations. So we get r times 1 minus p times k is equal to 0 to infinity k times k plus r p r 1 minus p k plus k is equal to 0 to infinity k plus r p r 1 minus p k. So this is equal to r times 1 minus p. Okay, so and let's make a substitution here. We say r is equal to s minus 1 as we did in the mean standard procedure. So k is equal to 0 k plus s minus 1 p to the s minus 1 1 minus p to the k plus k is equal to 0 to infinity k plus s minus 1 p s minus 1 and 1 minus p to the k. And okay, so which is equal to is p over p. So what I'm going to do is I'm going to bring this p outside and then this p outside. So then I have k is equal to 0 to infinity k plus s minus 1 s minus 1 p to the s 1 minus p to the k plus k is equal to 0 to infinity k plus s minus 1 s minus 1 p to the s 1 minus p to the k. Now note that this first summation is nothing but the expression for the mean of a negative binomial with parameter s. So the first part is, so outside we have r minus p over p. So the first part is s times 1 minus p over p. And second part is just the summation of the PMF of the negative binomial. So this should equal to 1. Now this can also be proved by using that power of a geometric series which we did some time back. But the easiest way is to recognize that this is a PMF, so all PMFs should sum to 1. So this is the second moment. Now if we say variance of x, this is equal to e to the x squared minus e to the x squared. So this guy is what? R times 1 minus p over p squared. Okay, now if you do just basic algebra, you will end up with r times 1 minus p divided by p squared. So this is actually the variance of a negative binomial random variable. Now note that I have skipped some steps here from here to here, and this is just basic algebra. I have used s is equal to r plus 1 and then use some basic simplification techniques to come to this result. If you don't want to, then you can leave it at this minus this, and if you are using a machine to calculate the variance, you will get the same answer. This is just for the simplification and some decorations here. This is it for the variance of a negative binomial random variable. So next we'll start with the Poisson distribution, which is very important discrete distribution. Thank you for watching. Hope you like the video.